DSP and MPP, discrete signal processing, and massively parallel processors. These are concept ideas, ways of looking at things, and when you look at something, you actually do this yourself. When you see something visually, that signal turns on some processing. Do you recognize this thing? Can you smell it? Can you touch it? Can you hear it? So we turn on these signals. Simply put, that's what they are. Your eyes are giving a signal to your brain. Your ears providing a signal to your brain, each one with discrete properties, right? And the word's not coming to me. Spectrums, discrete spectrums of energy transfer. Touch a hot stove, you get burnt, that's energy transfer. Hear music, that's energy transfer. This is really a simplest model, but so discrete signal processing, it's something we do every second of every day. The human eye sees it about 30 frames per second, which probably means each eye is seeing 15 frames per second. Or, how do you know? You research, you do studies, and the answers are probably out there for it. So discrete signal processing, a huge thing. Let's look at another place that's used. Telecommunications, radio waves, airwaves, television, TV, the internet, however it's delivered to you, is discrete signal processing. Specific energies at a known frequency and what goes on around them. So this signal processing idea, discrete signal processing, is a domain of sciences in itself. It is a specific domain in our military, in our security systems, in our communication systems. Discrete signal processing. How can I keep my signal from your signal? And if you find my signal, how can you decrypt it? This is not new. This is something that's been going on since we invented radios. So discrete signals are all over. This was something, a chemical plant with thousands of input-output points and thousands of other discrete processors like chromatographs, temperature sensor arrays, exterior alarm systems, measurement systems, external inputs, even a keyboard in somebody's office. So the discrete signal processing, it's just a different term for what's going on. Where does that lead to massively parallel processors, MPP? Another great question. In order to process these signals, there's computers, little chips, doing a whole bunch of work to turn numbers into meaning and passing that on somewhere else. It's a relational database running terabytes of near real-time information and storing petabytes of information off into a cloud somewhere. Largest industry on the planet, information processing. So these parallel processors, as powerful as they are, supercomputers running parallel processes in order to build your visualizations of today. That weather prediction that comes from NOAA is running on one of the largest supercomputers in the world. The software on it was ported from previous software versions, previous languages, to try to keep it up to date with the changes, the evolution of supercomputers. So this is just what's going on out there. That amount of processing. All it can do is draw a weather prediction on a board. So that weather prediction might or might not be accurate. And they are fairly accurate, reasonably accurate, when the weather's calm and the changes are slow and rolling. But as they speed up, we need more power to make better predictions because the extremes are changing. So more supercomputers are thrown at. But at all that time, keep in mind, massively parallel processors, not just one supercomputer, herds of them, some feeding others because they're too fast for the old technology out there. So you have to feed these things to keep them busy, and it costs thousands of dollars an hour and a whole lot of paperwork to get in the door to use it. That's massively parallel processors, something that has evolved. Watching 4 decades of it. That's the artificial intelligence people dream of or speak of. And as intelligent as it is, petaflops per computer. Dozens of computers petaflopping out there working on the same problems, trying to share information and build on a model that we've been building on for decades now, just to predict the weather. And yet, our mind is what analyzes that and looks at it and tries to make heads or tails of it. A human mind, a single human mind, which could be compared to a massively parallel processor. I hate these analogies from organic into computer systems, but there is an analogy there. You have a left half of your brain and a right half of your brain, and down at the base of it is the master operating system. That's such a false parallel because we are so far from that. Google answering a question is a finger on the question of AI, not the answer. But maybe one day we'll get there. Concepts. Pieces out.